Okay, good morning. I'm out in Retter, and I guess I've been in some way involved or contributed to eXist since about 2005. Don't know what I've been up to. I tend to try and just add in lots of features that people ask for, because it's quite rewarding. But when I'm not doing that, I kind of fix bugs on the project and try and sort of advance it. So what I'm actually not going to talk to you about today is RESTful XQuery annotations, because that's the talk that I'm going to give on Sunday at the conference. So I'm afraid you have to wait until then. But Project Sleepy is the implementation of RESTful annotations in eXist-db. And I might do a short demo of that this afternoon if I'm persuaded, but I don't want to let too much out of the bag before Sunday. So, what I'm actually going to talk about today is pretty much top secret, which is why I misled everyone and gave them a different title to my talk. So what I'm going to talk about today is security in eXist-db. So, in the past, I'm really talking about the current stable version of eXist-db 1.4, 1.41, and versions that have gone before it. We had a Unix, we called it a Unix-like security model in eXist-db. And it was Unix-like because I suppose it was inspired by Unix, but it wasn't quite the same in a number of ways. So the first thing was we didn't have a group user like you would have in Unix that's all powerful. We had sort of the combination of an admin user and a DBA group. And any user that you put into the DBA group was all powerful in the database, just as they were a root user in Unix. And Unix uses sort of read, write, execute flags. And we didn't have read, write, execute. We had read, write, update. But update is a little bit confusing because it was really only used if you executed XQuery update extensions or XUpdate against the database. So it was very much the same as write, but it just applied to XQuery updates. And we didn't have any control over execution, so there was no execute flag anywhere. Okay. In addition to that, in eXist you can create eXist-db users and groups, okay, so you can manage logins and this kind of thing. But previously they were all stored in a single XML file in the database, in a special collection that we call the system collection, where we try and keep the config for eXist, which hopefully nobody really directly interacts with, but it's sort of there and you can look at it and see what's there. Okay. So, in this talk, there's sort of it's sort of split half and half for users of eXist and half and half for developers of eXist. Because the work that I've been doing on security has taken probably the best part of 9 months, and quite a few of the developers on eXist haven't actually had much visibility of that. So I'm going to talk about some of the technical internals as well. So internally in eXist in the past, you had two different models for permissions. You had an on-disk model and you had an in-memory model, and they weren't the same. And the biggest problem was that the in-memory model was incredibly, how to describe it, unoptimized. So if you open a document in eXist, obviously you need to check the permissions. Does this user or group have access to this document? And that was all based on string comparisons of the username and the group name and this kind of stuff. And string comparisons, when you're trying to sort of work out if you can open 1 million documents when you perform an XQuery over a large collection, turn out it's not very fast. In addition to that, no, I don't have anything in addition to that. There's obviously translation when you load the document as well from the on-disk structure into the in-memory structure. So on disk we just have an ID for the user, and then when you open the document you actually have to go and look in the user's database, pull out the username, assign that to the document, and then when you want to check can they access it, you have to do all this string comparison. So it really wasn't very efficient. And it took up quite a lot of space in memory, and it certainly took up more space on disk than you needed. So, problems with this, so I've mentioned the string comparison. So each time you want to validate a user, it was quick, but it wasn't fast. Changing the XML file, so as I said, users and groups were stored in an XML file in the system collection. Well, if you had permissions, you could go in and you could twiddle this users file manually, so you could try and add users and groups into there, or change their permissions. Unfortunately, the representation of that file is also kept in memory by eXist. And you could end up in an inconsistent state where what was in memory was not the same as what you saw in the database. So you could twiddle that file, but you were never quite sure if it was going to take effect immediately or later, or what sort of state you would be in. As I mentioned, there was no control over execution, so we didn't have execute bits in eXist. So we couldn't say, only these users can run these X queries or XSLTs, which I think is a bit of a problem if you write X queries that do some quite powerful things like manipulate the database. In addition to that, some of the permission checks in eXist-db 1.4 weren't what I would call correct. So they did check for permissions, but maybe they didn't check for the right permissions. So when it was meant to be checking for read or write, it was actually checking for write or read. So the implementation didn't really adhere to what Unix prescribes. In addition to this, there was no centralized security manager. So you ended up with lots and lots of different types of security checks littered throughout the eXist-db code base, with no one place managing how the authentication is done. A nice to have also is user and group metadata. There was nowhere in eXist-db to directly associate metadata with users and groups in the past. Okay, you had to create your own XML file and put your group username or password in, not password, but username or group name in there, and sort of manually manipulate this stuff with XQuery. And it was too simple, predominantly because of the metadata thing, but also because you've only got users and groups. Okay. So what we often found was that when users were building large XQuery applications, they would write their own authentication layer in their XQuery app, where they would keep their own users and groups in XML files in the database, and then they would try and map that back onto one or two eXist-db users, which is quite problematic. There's lots of security issues with that. But we also got to the point where we found out that we as developers on eXist-db were doing this ourselves when we were writing complex XQuery applications. And that's kind of where I got to about 9 months ago. I was working on a large project that had very, very complex security concerns, where they wanted to basically produce a sort of online document management system. And they wanted very fine control over who was allowed to view what documents. And I started by trying to use the eXist-db built-in system, and then building layers and layers and layers on top of this to manage it in XQuery. And it got to the point where what I actually wanted to achieve just wasn't possible. So I decided that I would basically go back into the laboratory. And I spent probably between 9 and 6 months working on this. And it was quite nice in some ways because a lot of this development was sponsored. So I have to say thank you to particularly the University of Heidelberg, who sponsored all of the initial security work, and also the University of Richmond, who sponsored my time to finish it, which is how I can be here today and talk about it. Oh, and Dmitry Shabanov worked on a lot of the original security parts, particularly Realms, which we'll talk about in a minute, and obviously I worked on quite a lot of it as well. So, what did we do? We completely redesigned security in eXist-db. So there's now a centralized security manager, and this was really the initial sort of impetus by Dmitry Shabanov. And all sort of permissions, checks, and security and management for users and groups and authentication all goes through the central security manager. It makes sort of maintaining the security of the system much, much easier. We have support for multiple realms. This is something that Dmitry added as well. So we can now authenticate not only against eXist, but against LDAP, OpenID, OAuth. And the realms are pluggable, so if you want to authenticate against another system, you can very easily write a module for eXist that plugs in and you can authenticate. We now have proper Unix-style permissions, so we don't have read-write update anymore, we have read-write execute. And there's a story about that, because to achieve this I had to improve the performance of it. I'll talk about that in a minute. After I was done with that, I added access control lists. So eXist now has a full-blown access control list mechanism. So you can do incredibly powerful security constraints in eXist. In fact, so powerful sometimes I get confused when I'm trying to understand exactly what I did and why my user won't authenticate. But I'm going to try and explain it in a simple way later. So I mentioned permissions now follow the Unix model. That's not just the read-write execute bits. We've got set UID, set GID, and sticky bits, but they're not exposed to the user yet. That's further work. And we also try to enforce permissions to follow the Unix model. So if you want to change the group of a resource, you actually have to be in the group that you're trying to change the group to, because Unix enforces this, and there's good reasons for that. And this was never necessarily enforced in eXist-db before, so there's a lot more security constraints than exist. On top of that, we improved the password security, and I've got a slide on that later because it's a bit of an issue of contention at the moment. And the whole thing is extensible, so you can write modules for realms, right? So, centralized security manager, as I said, all security tasks are managed by the security manager. It's configurable, so if you look in the system collection in Exist now, there's a security collection in system, and there's a config file in there, and in there you can configure different realms of authentication. Okay? And storage is no longer a single XML file, which has all your users and groups in it. There's one file for each user and one file for each group, and they're on a per realm basis, so each realm maintains its own. And they're transparently synced with the in-memory model. So if you want to go into the database and mess around with the user's XML or the group's XML, you can do that, and the in-memory model will be updated as soon as you commit that document. So you shouldn't get into any sort of inconsistent user or group states. We also commit storing metadata now for users and groups, and with some of the realms that can be sort of extracted automatically from Active Directory. So if you've got your users' email addresses and first name, last name, office location, phone number in Active Directory, that's now accessible in Exist as well. So multiple realms. So there's the eXist-db internal realm. That's the default, and at the moment it's always switched on. We could potentially in the future offer an option to disable this, but at the moment that's where the admin user for the DB lives. So when you first install Exist, you have this admin user, because you need to log into the system somehow. So we're not thinking about disabling that at the moment, but if somebody gave me a really good use case where they wanted to disable it, we could maybe make that happen. So apart from eXist-db, I mentioned we've got LDAP. It also supports Microsoft Active Directory. Exist Solutions have a fairly large customer that are using that with their Microsoft Active Directory to authenticate a few hundred users. It seems to be working quite well. There's support for OpenID and there's support for OAuth. I haven't written much about those because I haven't implemented the OpenID or OAuth ones myself. That was Dimitri. So I don't know a great deal about them, but I'm going to be trying to find out more and document it very soon. So the security manager. So what happens if you have multiple realms and you want to authenticate a user against the security manager? It will basically, if you just give it a simple name like Adam Retter as the username, it will basically round robin against the realms depending in the order that you configure them, right? So it will try the eXist-db internal realm first. If it doesn't find a user in there, it will try your Active Directory and then potentially it will try your OpenID. But what you can also do is you can postfix the user with the realm ID. Okay? So if your Active Directory domain is ad.domain.com, you can say adretter at ad.domain.com, and it will only be authenticated against the LDAP realm. And you can use these as user IDs in Exist for any operation as you would normal eXist-db user IDs. And you can have accounts on them being eXist-db accounts and some being OpenID accounts and some being OAuth, so you can really mix this stuff up. Okay, so this is what realm configuration looks like for Active Directory. So the security manager is configurable and you can plug in realms. So you've got the security manager at the top and realm underneath. And then this is all the kind of stuff that you need to tell Exist about to talk to LDAP. Because different LDAPs use different attribute names for different things, different attribute names for usernames, passwords, all this kind of stuff. Because LDAP is ultimately configurable, right? So this is an example for Active Directory. So in Active Directory, the name comes from an attribute in their LDAP called Sam A account name, right? So you have to sort of fill this stuff out, but the Active Directory one's pretty much always the same for any Active Directory. But the cool thing is that I've also bounded some metadata from Active Directory. So I've said, oh, you can look in the Active Directory for an attribute called name or mail, and that will extract their in this case, their surname and their email address, and it will make it accessible in eXist-db. So in your X-queries and stuff, if you want to send an email to somebody, you can say, oh, it's this user, just give me their email address. So you've got this sort of account configuration and you've got group configuration. We also have support for whitelists and blacklists, because maybe whilst you want to plug into your Active Directory, you don't want all Active Directory users being users of your eXist-db applications. Okay? So you can whitelist or blacklist groups or accounts, okay? And you can list as many principals as you want. So you can This just says all Active Directory users, all the domain users are accessible to eXist-db, right? But you could put in my special users from Active Directory here, or whatever you want to do. So, Unix style permissions. So I talked earlier about in eXist-db there was a lot of string comparison going on. They weren't very performant. That wasn't my initial interest. What I really wanted to do was implement access control lists in eXist-db. But I was warned that it would be too slow. So I decided that if I could improve the performance of the existing permission system significantly, I would then have license basically to implement access control lists as well, providing it was fast. So I did. So what I did is I came up with this idea that in computing everybody talks about, oh, you should use this data type or you should use this data type. So I just went very simple and said, well, every single bit in every byte is important. And also that computers are very, very good at binary math. So if you can give them numbers to do comparisons against sort of ANDs and ORs and XORs, it's very, very fast. So now inside eXist-db, there's two things. There's no difference between the in-memory model for permissions and the on-disk model. There didn't really need to be before. I'm not sure how we ended up with that, but it's very fast now because whatever it loads off disk goes straight to memory, and that's the thing we use. And everything is based on a number, so we don't do any string comparisons anymore. So we use numbers for user IDs, group IDs, and for the permissions. But integers are quite big, so integers are 32 bits. And I didn't really want to use 32 bits because I wanted to make this nice and small and fast. So what I realized is that it's unlikely that anybody's going to have more than whatever that big number is there, 1 million users, okay, or 1 million groups. Certainly in sort of institutions that we're working with, and we can maybe up this limit in the future. It's not set in stone though, but for the time being, I've limited it to about 1 million users or 1 million groups. And what that means is that user IDs and group IDs don't take up 4 bytes anymore. They only take up 20 bits each. So I can save some space there, and then if I save some space there, well, I can use that space to put the permissions mode into there. So I kind of mash all this stuff into a single big bit stream. Okay, so a big bit map. But all of this sort of saving ended up meaning that permissions in the new eXist-db are 41% smaller than in the original eXist-db, and we don't do any string comparison. And on disk it looks a little bit like this. So we store a user ID, then we store whether the user's set UID, the read, write, execute flags for the user. We then store the group ID, set GID, read, write, execute flags for the group. Sticky bit, so set UID, set GID, sticky bit, they're not exposed to the user yet, but they're all there. That's coming soon, I think. And then read, write, execute for other users. Okay. And we store it this way because this is the way we read it. So when you do a permissions check in eXist-db, the most significant thing is the user. So is your user the owner of the document that you're trying to access or the collection you're trying to access? Okay, so if it's we can just use the first 20 bits to tell you can access this resource. Okay. So this becomes really, really fast because we don't even have to read all 52 bits. We can just read the first few to work out if we can access the resource. Okay, so once I was done kind of speeding up permissions in eXist and making them much smaller in memory and on disk, I was pretty happy with that. So I was like, okay, permissions in eXist are really fast now, so I can have more of them. So I decided to implement access control lists. Access control lists in eXist-db are fairly simple layout. So I tried to implement, does anyone know what ZFS is? Yeah, okay. So ZFS is like a really advanced file system from Sun. And they have access control lists that are really, really cool. So I tried to implement those in eXist-db and just found out it was way too much work. And then there's something called, does anyone know what NFS is? Network File System for Unix? Yeah, okay. So NFS v4 has its own ACLs, which are pretty standardized now. So I tried to implement those as well. And I'm still planning to do that, but it was just way too much work. Okay, and we didn't really need everything that NFS ACLs offer, but we'll probably will get there. Anyway, so on every collection and resource in eXist-db now, you can add an access control list, okay? But these complement the Unix style permissions, so you still have the classic owner, group, and permissions mask, right? Read, write, execute. And on top of that, you can add additional entries to this access control list. So you can say, oh, but also this user has this permissions, or this group has this permissions. And you can build up this whole list of access control. Okay. Basically, it resolves many of the limitations that we had in the past. So I don't think people are going to have to build their own authentication or user management layers in Xcree and XML anymore. I think we have everything we need now built into Exist to do this. It's quite flexible, and I'll show you how. An ACL itself just takes up 1 byte, so it's almost nothing, because it's just a pointer to the number of access control entries that are in the list. Okay. So an ACL comes for free, pretty much. But it's the access control entries in the ACL that take up space. So in the access control list, we always evaluate from top to bottom. So if you have an entry at the top that says this guy's blocked, and you have an entry below it that says a group that he's in is allowed, well, he's going to be blocked. Okay? Because we always evaluate top to bottom. We exit as soon as we match. So when you place an ACL on a collection or on a resource, the content of the access control list is always evaluated before the Unix style permission, so before we evaluate the owner or the group of the resources. And that's because that's the only way it works. Originally we tried to do it the other way around, but it just doesn't work. Too many of the sort of things that you want to do are impossible. And actually, when I then thought about it and looked at ZFS, that's exactly what they do as well. The ACL is always evaluated first. So it's very, very powerful, and I'll show you why. But it's difficult to master, it can be confusing. So I'm expecting a few people to have a few posts on the mailing list saying, I've got this ACL, but it's not doing what I think it's doing, and I'll probably say it's because it's not doing what you think it's doing. So we'll have to have a talk about that. But so your access control list is full of access control entries. It associates an individual group or user with access rights, and it consists internally of 4 things. So target types. So we need to know whether you're putting this permission on a user or a group. Okay? And then on top of that, we need to know who the user or the group is. So we have their ID. Then we have a mode, and the mode is just 3 bits, so it's read, write, execute. So you can write read, write, execute. And on top of that, we have an access type allowed or denied. So you can have a whole bunch of access control entries where you say, oh, this group is allowed read and write, but this user in this group is allowed execute, or this user in this group isn't allowed execute. So they don't just grant permission, they also deny permission, which is why they get quite complicated. They're preserved across backups. So if you back up eXist-db now, and you look in your contents XML file, you'll see access control entries on your resources and collections, if you value them. If you go into the Java admin client for eXist-db, you'll see a little plus on the permission side if there's an access control list entry on it. So on disk, it's just 29 bytes. It's not very exciting, but it's nice and succinct, but it's nice and fast. So, when it's serialized, it looks a little bit like this. Okay? And there's a function in eXist-db called security manager get permissions exposed to the Xcree now. And you can call that, right? And you'll see the original Unix style stuff, so you'll see the owner, the group, and the mode. And then you'll see the ACL, and it tells us we've got 2 entries, and these are the entries. So what this is saying is only the admin and the DBA have read-write access to whatever this resource or collection is, right? But what I'm going to do is I've got this user Adam, and he's in the group users, okay? And I want everybody in the group users to be able to read and execute the resource. But I don't want Adam to be able to do anything with it. So what I do first of all is I block off Adam, deny, read, write, execute. Okay? And because he's at the top of the list, if Adam tries to access this thing, it's going to find him here and go, no, you're not going through. But if you're not Adam, and you're in the users group, so group users, and you try to access the resource, well, you're allowed read, execute. Okay. And you can have up to 255 access control entries in a list at the moment. Okay, I've kept it purposely small to keep it fast, but we could potentially expand it in the future with a few more tricks. But I think 255, if you imagine there are 255 groups that you put in there, that's quite flexible. Okay, access control list demo. So I was going to do a little demo showing you how this all works in Xcree, because we've got a new module in Exist, which has lots of functions for manipulating access control lists. Unfortunately, I'm not going to have time for that, but maybe in the eXist-db open conference, unconference bit later, I can do that. So as I said, permission enforcement. So we've aligned ourselves with the Unix permissions model completely. Permissions were enforced really. So we use aspect-oriented programming to do this, because permissions are cross-cutting concerns. If you're working on the internals of eXist-db, it's now really easy. You can just add this Java annotation to your functions called @permission_required. And it has a few flags that you put on there, like you must be the DBA, or you must be a user in these groups, or a member of a group. And you can put that on any function. So if you're writing extension modules for Exist and you want to enforce some weird and wacky permissions on your functions, you can just add this annotation. And it's really secure because it's woven in at compile time. Okay? So you can't change it at runtime. And then, in addition to that, some of the permissions calls at the moment are done with permission.validate, which goes through the security manager. But last night I figured out how to extract those into permission required as well. So everything, all the permission stuff will be done by AOP. So anyone can use it. All operations on the database should be checked. All operations on users and groups should be checked now. If you find something that you think smells a bit fishy, like it's not checking it properly, or you expect something different, let me know. This is all fairly new stuff, so there may be issues. The DBA group is still like the root, so they're still all powerful. But I've had a few emails on the Exist mailing list recently saying, my application is broken, what's going on? Or, I hate this, I want to rip out the permissions. You will need to make a few changes to your application because Exist never really enforced permissions as strictly as it should have in the past. So you may find that you now get permission denied errors in your application, but it's probably because the permissions that you've set in the database aren't as strict as they should be. So you may need to tweak your application a little bit. So please just keep that in mind, okay? It's not a problem probably with the security system. It's probably that you just need to tweak the permissions in your application. So please don't start riot and burn me. Okay. So password security, we used to use MD5. MD5 was secure once, it's not anymore. So we now use RipEnd 160. I've been given quite a lot of flack over this for not using SHA. I have reasons for not using SHA, which is that SHA1 itself is insecure, so I have to use SHA2. SHA2 requires 256 bits. I think there's a better alternative called RipEnd 160, which only needs 160 bits, so it's probably faster. SHA is also developed by the NSA in the US, and it's developed in a closed environment, so you've no idea what's really in the SHA algorithm, right? Whereas RipEnd is an EU-funded project, it's open, it's well documented, it's well understood. So, we're not going to do questions unless anyone has any pressing concerns, because I'm being told I'm running out of time. Any questions at all?
Good work.
Good work. Yeah. Okay. So, this is what I think eXist-db now looks like.
You will be doing a demo probably this afternoon.
Right.
This week.
Thanks.